Good afternoon. We are continuing our work involving dy dx, so finding the differentials of equations. So what I've got here is some index laws just to remind you, because these will become useful as we move into it. So what I want us to do today is I want us to find dy dx. Find the dy dx of each of these. So for example, my first one is going to be y equals -3 x to the power times x to the -2. So what is that differential? What is the differential of that one going to be? And then I'm going to write, I'm going to do a couple more. And quickly do one more. All right. So these are the three I want us looking at right now. So the first one is already written in index form, so it should make our lives much easier. So all we need to do is we need to follow our dy dx pattern. We're going to take the -2, slam it down the front, and then we're going to subtract 1 from the power. So my new equation will start off dy dx will be equal to, so it'll be -3 times -2 times x to the -2 minus 1. So that's actually going to be -3. All right, so the power is decreasing when you're involving the negative powers, which means that dy dx is going to be equal to 6x to the -3, or 6 on x cubed. All right. Generally, when we are writing these, we want to express everything using positive powers where possible. So, although in this case, I would accept either 6x to the -3 or 6 over x cubed. All right. It all depends on what the question is asking. If the question doesn't specify a form, then we don't care. However, if it says use only positive indices, you would have to convert it to the fraction, because we don't want to see any negative powers. All right. So this next one, we have to do something to it first before that we can do dy dx to it. Does anyone want to start us off in the chat? Yep, inverse of x to the 4. That's what we want to do. So we want to turn this into index form. So that we recognize that 1 on x to the 4 is equal to x to the -4. So we recognize that. So then we rewrite it. We rewrite what we've got here and we will now rewrite it in the form that we need, which is 3x to the negative 4. Now we can do our dy dx. So from here, dy dx, we're going to take our minus 4, whack it down the front. So it's going to be 3 times negative 4 times x to the negative 4 minus 1, negative 5. All right, and then from here, we have negative 12x to the negative 5, which we can then express using a positive indice of negative 12 over x to the 5. All right. Now, last one, a little bit different. All right, because it is written how your CAS would present it to you. If you were, for example, doing a bunch of stuff using differentiation, using fractions and negative powers, you might get something that looks like this as your answer. All right, but we can't do anything with it further to find the differential of this because we have to split it up. We have to split it into fractions, but we also have to split it so that we can put everything into negative powers. So there are two ways that you can do this. One may be easier than the other. But so what we're going to do is I'm going to remind you that if I have a to the n divided by a to the m, then that simplifies to a to the n minus m. All right. If we have that rule, we can make things a little simpler for us. We don't have to do any extra stuff. So this we'll call this method 1. Taking advantage of this property here. All right. So I'm going to split this into 2x3 divided by x to the 6 plus 5x4 x to the 6. And from here, I can now use this rule here to simplify things down. So what does 2x cubed divided by x to the 6 become? Following along with a to the n over a to the m equals a to the n minus m. You might have seen it with m on top and on bottom, whatever. The principle is the same. So it's going to become 2x to the 3 minus 6. So what is 3 minus 6? Yeah, it's 2x to the negative 3. And then the other one is going to become it's going to become 5x to the negative 2. So now we have something that we can work with. Okay? So we can now work with this. And then we can dy dx it. Take that, whack it down the front. Take that, whack it down the front. And we have 2 times minus 3 times x to the negative 4, because we've subtracted 1 from the top, plus 5 times minus 2 times x to the negative 3. And then we can gather everything up. So that's going to be minus 6 x to the negative 4 plus, minus 10 x to the negative 3. And then we can express that using positive indices by having negative 6 over x to the 4 minus 10 over x to the 3. By the way, guys, are there going to be asymptotes on this if we were to graph this? Am I going to have asymptotes anywhere if I were to draw these? Yes. Where are those asymptotes going to be? Where are those asymptotes going to be? What can't I have as a value for x? Not a positive value. Remember that if I were to put x equals 1 in here or x equals 2 in here, I'm going to get an answer. But if I put x equals 0 into here, in fact, into any of these, what's going to happen? Yeah, oh, okay. So for all of these, I haven't explicitly written it out, but remember for each of these, x cannot be 0. All right, x cannot be 0. It can be negative, it can be positive, but it can't be 0. All right. It's kind of weird how that works, but you know, here we go. So I will put this video up. I will put this screenshot of the working out up, and from there, you should be able to have a go at the questions from 17C. Now, some of the questions from 17C mentioned first principles. No. Just no. All right. You are not expected to do first principles on this stuff. Oh. Someone has just asked me an excellent question. I talked about 2 methods to solve this last one. What's the second one? That is an excellent question. That is an absolutely bonzer question. So I'm going to go over here. I'm going to use a different index law. Yeah. So there's a second way to solve that question. Now, it's called math methods for a reason, because there's multiple methods to solve the problem. Depending on how you think about it, it might be easier to do one way than the other. So I'm just going to quickly rewrite this one down. Oh, I'm going to just go over here. Never mind. So this is all, so for example, so this is 2x cubed plus 5x to the 4. And what I can do is I can express this as being all times by 1 on x to the 6. If I convert 1 on x to the 6 to x to the minus 6, 2x cubed plus 5x to the 4, I can take advantage of a different index law. So for example, if I'm doing if I do a to the m times a to the n, I can change that to become a to the m plus n. So what I can do is if I expand this bracket, x to the minus 6 times x to the 3 would be equal to minus 6 plus 3, which means that I can just expand this and use this rule here, and I still end up with the same answer. And then x to the minus 6 times 5x to the 4, that's minus 6 plus 4, 5x minus 2. Okay, so I end up in the same place to do the rest of my stuff with, but how I get there is different, using different index laws. Depending on what works best for you, that's the one you use. All right, both ways of doing it are correct. That is an excellent question, and thank you for reminding me. All right, now I'm going to stop the video.